All right, so if you're a developer working in AI, you've definitely asked yourself this question. Which vector database should I actually use? It's a tough call, right? Especially with new options popping up all the time. Today, we're going to cut right through all that noise and focus on one specific, super powerful category, the lightweight in-memory libraries.
I mean, it seriously feels like every single week there's a new player on the scene, and they're all promising to be the perfect solution for your next big AI app. Now, this boom is exciting, for sure, but it also creates a massive challenge for us developers who are just trying to pick the right tool for the job.
Just take a look at this. You've got everything from fully managed services like Pinecone to open source giants like Milvus and Qdrant, and then you have extensions like pgvector. Honestly, it's enough to give you some serious analysis paralysis. So how do you even begin to choose? Well, the very first step is to understand one really crucial distinction.
To make sense of all this, we need to split the world of vector search into two major camps. On one side, you have the lightweight libraries, and on the other, you have the full-fledged databases. They solve very different problems, and trust me, knowing which one you need is already half the battle.
Okay, so think of a vector library like a specialized, high-performance part you add to your car's engine. You integrate it into your own application to do one job, and one job only: lightning-fast similarity search. It's not a whole data management system, it's a very focused tool. It's absolutely perfect for research or for apps where your vector data isn't changing all that often.
Now, a vector database, that's the whole package. It's a complete system built from the ground up to store, manage, index, and query your vectors. It handles all the heavy lifting, things like data consistency, backups, and scaling. This is what you're going to need for production applications with data that's constantly changing, like a real-time e-commerce recommendation engine. And this right here breaks down the core trade-off perfectly. Libraries are absolutely king for quick prototyping and research. Databases? They're built for production. A library gives you that one specific, powerful tool, fast Approximate Nearest Neighbor search, while a database gives you the entire suite of data management services. So the real question you have to ask yourself is, do you need a scalpel, or do you need the full surgical kit?
So for the rest of this explainer, we're going to focus on the scalpels, those powerful, lightweight libraries that are absolutely perfect for getting a prototype up and running incredibly fast, or for when you just need that one killer search feature. So let's meet the big four. What's so fascinating here is that many of these actually started inside huge tech companies to solve their own massive search problems. We've got FAISS from Meta, Annoy from Spotify, the incredibly influential open-source HNSWlib, and ScaNN from Google. First up is FAISS. If you need just raw, unadulterated speed, this is often your go-to. It was developed by Meta's AI Research Lab, and it is highly, highly optimized for performance, especially if you can throw a GPU at it. It's an incredibly powerful tool for machine learning workloads where every single millisecond counts. Next, we have Annoy from Spotify. And you gotta love its full name, Approximate Nearest Neighbors. Oh yeah. That pretty much tells you everything you need to know about its philosophy. Keep it simple. It's designed to be super lightweight and incredibly easy to plug into your project. For those moderate-sized datasets where you want minimal fuss and just want something that works, Annoy is a fantastic choice. Then there's HNSWlib. This one isn't from a specific company, but it is a massively influential open-source library. It gives you a highly optimized implementation of the HNSW algorithm, which we'll talk about in just a second. It strikes this amazing balance between search speed and accuracy, which is exactly why it's the engine hiding under the hood of so many other bigger vector database systems. And finally, ScaNN from Google. While all these libraries are fast, ScaNN's real claim to fame is its focus on high accuracy. It uses some really clever techniques to cut down on errors, which makes it an excellent choice for things like semantic search and NLP, where getting the most precise match is absolutely critical. Okay, so we've established these libraries are fast, like ridiculously fast. But how do they actually do it? Let's pull back the curtain for a second and look at the core tech that makes it all possible. This is the key question, isn't it? If you have a million vectors, the old school way, a brute force search would mean you'd have to compare your query to every single one of them. That is way too slow. These libraries do something much, much smarter. The secret is a concept called Approximate Nearest Neighbor search, or ANN. The core idea here is a brilliant and really practical trade-off. Instead of wasting time finding the absolute 100% perfect closest match, these algorithms promise to find something that's very, very close to the best match. And they do it orders of magnitude faster. For most applications, this good enough result is more than perfect, and that speed gain is a total game changer.
So one of the most popular ways to do this is with an algorithm called HNSW. Think of it like navigating a city. You start your search way up high on the highway layer. There are only a few entry points, but you can cover long distances really quickly. You find the exit closest to your destination, then you drop down to the main roads layer, navigate a bit closer, and then you drop down to the local streets to find the exact address. By starting broad and getting more and more specific, you find your target without having to drive down every single street in the entire city.
Okay, we've covered the difference between libraries and databases, we've met the key players, and we understand the tech that makes them so fast. Now, let's put it all together into a practical framework to help you choose the right tool for your project.
Let's make this super practical. Think of this as your cheat sheet. If your goal is just fast local prototyping, a lightweight library like FAISS or Annoy is your best friend. Building a huge production-scale AI app? Then you should be looking at a managed vector database like Pinecone or Milvus. Already have a Postgres database you love? Just add the PG Vector extension. Using Elasticsearch? Easy, just use its vector search plugin. And for those giant enterprise workflows already living on a major cloud, use their built-in services like Vertex AI or Azure Cognitive Search. It's all about matching your goal to the right tool type.
You know, this quote really captures the exact moment we're in right now. Understanding this landscape isn't some niche skill anymore. It's becoming fundamental for building any modern AI application. Being able to navigate these choices is what separates a project that gets stuck from one that really succeeds. So, I'll leave you with this question. As you start thinking about your next project, that next prototype, or that next feature, are you going to start light with the simplicity and speed of a library? Or are you going to go heavy and jump straight to the power and scalability of a full database? The right answer depends entirely on your goal, and now you have the framework to make that call.